Hi everyone, I'm Ahmad from Vancouver. We usually think of artificial intelligence as software. We ask ChatGPT a question, generate an image, or write some code, and the answer appears almost instantly. But behind every AI response is something we rarely think about: electricity. Every prompt is processed inside a data center filled with thousands of powerful AI chips. Those chips consume electricity, generate heat, and require cooling systems to keep operating. As AI becomes part of our everyday lives, one question is becoming increasingly important. Can the world generate enough electricity to power the AI revolution? To answer that, we first need to understand the scale of AI's growing energy demand. The numbers are remarkable. In 2024, data centers around the world consumed about 415 terawatt-hours of electricity. By 2026, that figure is expected to reach roughly 565 terawatt-hours. And by 2030, projections suggest it could approach 950 terawatt-hours every year. That's almost twice as much electricity in just 6 years. To put that into perspective, 950 terawatt-hours is roughly equal to the annual electricity consumption of Japan. The biggest driver behind this rapid growth isn't video streaming or cloud storage anymore. It's artificial intelligence. But why does AI require so much electricity in the first place? Let's follow a single AI question. Imagine you ask ChatGPT to summarize a report or explain quantum computing. Your request is sent to a data center where thousands of GPUs work together to generate the answer. Those chips perform an enormous number of calculations in just a few seconds. All of those calculations require electricity. But that's only half the story. Almost every watt of electricity consumed by those chips eventually becomes heat. That heat must be removed continuously using powerful cooling systems, which consume even more electricity. So when we think about AI, we shouldn't just think about powerful chips. We should think about chips, cooling, and electricity working together. And once you realize that, another question naturally follows: who is building all of this infrastructure? When people think about the AI boom, they usually think about companies like OpenAI or NVIDIA. But AI depends on an entire ecosystem. OpenAI, Google, Meta, and xAI build the models. NVIDIA, AMD, and Broadcom build the chips that power those models. Companies like CoreWeave, Equinix, and Digital Realty build and operate the data centers that house those chips. Then companies such as Vertiv, Eaton, Schneider Electric, and Siemens Energy provide the cooling systems and electrical equipment needed to keep everything running. Finally, utilities like NextEra, Constellation, and Vistra generate the electricity that powers the entire system. AI isn't creating demand for just one industry. It's creating demand across an entire industrial ecosystem. And that brings us to the biggest question of all. The next chapter of artificial intelligence may not be limited by better algorithms. It may be limited by electricity. Today, companies can buy more GPUs, build larger data centers, and develop more powerful AI models. But none of that matters if there isn't enough electricity to run them. In many regions, new AI data centers are already waiting for access to the electrical grid because power infrastructure takes years to expand. That's why we're seeing massive investments in power generation, transmission networks, advanced cooling technologies, and even nuclear energy. The AI race is no longer just about building smarter models. It's becoming a race to secure reliable, affordable power. AI may look like software, but underneath it, it is one of the largest infrastructure buildouts the technology industry has ever seen. If you enjoyed this explanation, subscribe to Ask Wall Street. In our next episode, we'll continue exploring the technologies and industries shaping our future, one simple idea at a time.